If I multiply decagrams per container by grams per decagram by milligrams per gram, I'm left with milligrams per container. And the answer is 20,000. So if I look at these bar graphs as 9 plus 5 plus 6 plus 4 plus 3.5, my total is 27.5. And they tell me the number of installations is 27,500. So this is the number of installations in thousands. And that's the label that would go over here on this axis. So if I take 80 miles per hour and I multiply by 3 hours for the trip, hours cancels out. And I'm going to multiply by 1 gallon per 34 miles, so miles cancels out, and I'm left with a number of gallons per trip, which is going to give me right around 7.06 or 7. So if I take 400 characters per second and I multiply this by 1 word per 5 characters, characters cancels out, and then I multiply this by 60 seconds per minute, seconds cancels out, and this gives me the words per minute, which is 4,800. So if I start out with 7,000 meters squared, and I multiply this by the conversion factor of 10.76 feet squared per meter squared, I get C. So if our scale is 400 million miles of actual distance per 1 mile in the model, and we multiply that by some number x, which is the number of miles in the model, those cancel out, and I'm left with the distance, so it's 400 million x. So I have 3 different units in this problem: inches, feet, and yards. If I start with the dimensions as 18 feet, 42 feet, and 6 inches, I can convert those 6 inches to a half a foot. If I then divide all these by 3, I have 6 yards by 14 yards by 1/6 of a yard. The answer is A. Maybe it's easier to think of that 0.5 feet as 1/2 feet. That way, when you divide it by 3, it's the same thing as multiplying by 1/3. So we went from 40 kilometers to 42 kilometers. That's a change of 2 kilometers. And we're going to multiply this by 1 mile per 1.6 kilometers. The kilometers cancel out. And the answer is 1.25 when you take 2 divided by 1.6. So this glass holds 16 fluid ounces. So we're going to take 128 divided by 16, and we get 8.